Dear colleagues, this is a cataract with grade 2 nuclear sclerosis. The patient is under topical anesthesia. Let us observe this surgery. This is the main incision with a 2.8 millimeter steel keratome, and now this is phenocane, which contains lignocaine, tropicamide and phenylephrine. The antechamber is then filled up with 2% hydroxypropyl methyl cellulose. A side port is then done on the left side of the main incision, about 90° away. And now, with stereocoaxial illumination, we get very good red glow, and capsulorhexis is done with the help of Utrata forceps. Hydrodissection is done with 27 gauge cannula and BSS. You can see the fluid wave going to the other side, tap the nucleus. Now fill up the chamber with visco. And now here goes the Mohanta's prechopper. The prechopper is engaged in the soft part just in front of the main wound. The sustainer hooks the opposite equator, and the nucleus is divided into two heminuclei. In another few seconds, the one heminucleus is divided into two pieces. The other heminucleus remains as it is. And now the phaco needle is to be introduced. You must have noticed that I didn't rotate the nucleus after hydrodissection. This is just to keep the lens cortex, nucleus cortex mass stable, so that the prechopper, when the prechopper goes, the nucleus doesn't rotate mass. And now the phaco needle goes, the pieces are separated and they are picked up and emulsified. This is the other piece of the heminucleus, and this is the heminucleus which we have not divided. Now, so how easily we can divide this nucleus? There are some air bubbles which is causing some problem in visibility. The sustainer itself divides this heminucleus. This may be difficult in very rock hard cataracts to divide the nucleus with the sustainer, but in soft cataracts it is easy. Up to grade 3, no problem. Nowadays I try to remove a portion of cortex by the handpiece itself, but I don't encourage you to do this because I have ruptured 2-3 posterior capsules when learning this. There are very few cortex remaining. I am using a 23 gauge Simcoe to remove this cortex. There is a the epinuclear piece here. It comes, and now some fibers here and there, and a bit of cortex just subincisional, sub-main incisional. The patient is not much cooperative, moving the eye always, and I found it difficult to do it. Just to mention that the microscope is Lumera T from Zeiss. It has got a very good observer microscope with full depth perception for the observer. I bought this microscope for my passion to teach to the trainees that come to me from around the world. And now, since hydroimplantation has been done, there is nothing much to clean. The antechamber and the bag is not having visco. The side port is closed. a final lavage is done. I always do this. There is some visco that sticks to the corneal endothelium. I remove that at the last step, form the antechamber and conclude the case. Let us observe the main part, that is the pre-chopper part, in slow motion. This is in 50% speed. After hydrodissection, the antechamber is filled up with visco. Now the pre-chopper is taken in the dominant hand, in my case it is in the right hand, the sustainer in the non-dominant hand, in my case it is in the left hand. Now the pre-chopper goes, first the sustainer goes and makes the eyeball stable. Now the pre-chopper goes and it is placed just in front of the main wound, just anterior to the rhexis margin, engages in the soft part. The sustainer hooks the opposite equator. The two instruments are brought to each other and the two heminuclei are separated. The sustainer remains there, the pre-chopper remains there, the sustainer rotates the nuclear mass, hooks the heminucleus, and one heminucleus is divided into two pieces and come out. Thank you very much for your attention. Hope this video will encourage you to use pre-chopper in your soft cataract surgeries.